Alaikum. Today we are going to review Calculus 1 final exam. So I prepare for you some questions which we are going to do today. So let's start with the first question. So here they ask me to find the limit and they ask us to show the work. So when we have a question like the limit, so the first thing what to do is substitute for in x. So here if I substitute I will end up having 4 square minus 4 times 4 over 4 square minus 3 times 4 minus 4. So which mean I will have 16 minus 16, and here I will have 16 minus 12 minus 4, which mean I will have 0 over 0. So when you see that you have 0 over 0, it means that you can factor the numerator and you can factor the denominator, and they have common factor. So when you get 0 over 0, what to do? So take factor at the top, so you're going to be limit when x go to 4, x times x minus 4, and here I factor the denominator, so it's going to be x plus 1 times x minus 4. So now I cancel x minus 4, so we end up having the limit of x over x plus 1 when x go to 4. So what I do next, I substitute x by 4, so it's going to be 4 over 4 plus 1, which is 4 over 5, and this will be your limit. For second question, so here they ask me to find the limit of square root of x plus 2 minus 3 over x minus 7. Like again, first what we do is substitute, so it's going to be square root of 7 plus 2 minus 3 over 7 minus 7. So which will be square root of 9 minus 3 over 0. So it's 3 minus 3 over 0, which is 0 over 0. So again here I end up having 0 over 0, and if you have square root on the denominator or the numerator, so always multiply by the conjugate. So the conjugate of square root of x plus 2 minus 3 is square root of x plus 2 plus 3. So I will end up having what? The limit of square root of x plus 2 minus 3 over x minus 7. So x go to 7. Don't try to do L'Hopital's rule because you have 0 over 0, because you may miss the with the derivative with the square root. So it's better to use the conjugate. So here we'll end up having square root of x plus 2 plus 3 over square root of x plus 2 plus 3. So here is the same thing if I have a minus b times a plus b, which means I will have a square minus b square. So this will be equal to limit when x go to 7 of square root of x plus 2 square minus 3 square over x minus 7 times square root of x plus 2 plus 3. So here is the same thing as limit of x plus 2 minus 9 over x minus 7 times square root of x plus 2 plus 3. So I'm doing all the steps, but you can skip a lot of steps if you can see their idea ahead. So x minus 7 times square root of x plus 2 plus 3 when x go to 7. You see here it cancels out. So what's left is the limit of 1 over square root of x plus 2 plus 3 when x go to 7. Now I substitute, so I get 1 over square root of 7 plus 2 plus 3, which is 1 over square root of 9 plus 3. Square root of 9 is 3, so it's going to be 1 over 6, and this will be the limit for that question. The second limit question here. So here we have limit when x goes to infinite. So when we have infinite, so keep in mind that always the limit with the infinite, always the highest power of the numerator denominator, the one who equivalent to that limit. So if I have x minus 1 as square root of x squared, so this is the same thing if I do the limit when x goes to infinite of x over square root of x squared. So you may do the same thing. So if you take the highest power as common factor, so here I can do it in that way. So it's going to be x times 1 minus 1 over x over square root of 4x squared times square root of 1 plus 1 over 4x squared when x go to infinite. So here again I have a square root, so the x is square, so I can simplify here. So it's become limit of x over times 1 minus 1 over x over 2 to absolute value of x times square root of 1 plus 1 over 4x squared when x go to infinite. So x go to infinite does mean x is positive. So the absolute value of x will be equal to x. Keep in mind I make the absolute value here appear because if you got the limit when x go to minus infinity, so the square root of 4x squared will be minus 2x because when you do absolute value, and if x is less than 0, so absolute value of x will be minus x. So which when x is negative, because x goes to minus infinity means it's negative, so absolute value will be minus x. It's not absolute value of x is always positive, that means x is positive. No, x you have to see where it go. If it go to infinite, that means it's positive. If it go to minus infinite, that means it's negative. So when you take off the square root with the square, so always keep the absolute value and check the sign of x if it's positive or negative. If it's positive, keep x because it's positive. If x goes to negative infinite, change it to minus x. So here x is positive, so I will keep it as x. So here is going to be the limit of x times 1 over x over 2x square root of 1 plus 1 over 4x squared when x go to infinite. So when x go to infinite, this is go to 0. This is will go to 0 because 1 over infinite is 0. We cancel the x. So what's left is 1 half. So the answer will be 1 over 2. Like I say here, you see, it's going to be the limit of x over 2x because x go to infinite. We cancel, so it's going to be just 1 half. It's the same idea. So some professors like to see the work like that. Some they don't like this. So do what your professor like to see. All right, for this one, so when I substitute 2, I got 4 minus 4 over 0 square, which is 0 over 0. So I factor the numerator, so I have the limit when x go to 2 plus, so of x squared minus 4 over x minus 2 square will be equal the limit of x minus 2 times x plus 2 over x minus 2 times x minus 2, because this is what is square when x go to positive. So I simplify x minus 2. So it's going to be the limit of x plus 2 over x minus 2 when x go to 2 plus, which means that I will have 4 over 2 plus minus 2, which means that 4 over 0 plus, which is infinite. So the idea of the 2 plus does mean 2 is greater than, this 2 plus is greater than 2. It's like 2 point a lot of 0 than 1, for example. So this is what they mean by 2 plus. That means on the right side of 2. That means it's greater. So if we subtract 2 plus by 2, we always got something greater than 0 a little bit. So this is what we name it 0 plus. So 4 over 0 plus is infinite. Next question. So here, so if I substitute, I will get sine of 0 over tangent of 0, which is 0 over 0. So you may use L'Hopital rule. So if I use L'Hopital rule, keep in mind that this is a chain rule. Don't do the derivative of sine is cosine and derivative of tangent is secant. No, this is chain rule, so be careful. So if I have the limit, I will do it with the chain rule and with the I will do it with L'Hopital rule and without L'Hopital rule. So I will have sine of 3x over tangent of 5x when x go to 0. So if I use L'Hopital rule, I will have the limit of the derivative of sine of 3x, which is 3 cosine. So it's going to be the limit of 3 cosine of 3x over 5 secant square of 5x when x go to 0. So when I substitute, cosine of 0 is 1, so it's going to be 3 cosine of 0, and secant of 0 again is 1, secant of 0, so 1, 1, so it's going to be just 3 over 5. So this will be the limit. If I don't want to use L'Hopital rule, so I will have the limit, so of sine of 3x over tangent of 5x when x go to 0. So I will use those properties, the limit when x go to 0 of sine of ax over ax is 1, and the limit of tangent of ax over ax when x go to 0 is 1. So I will use this two property. So in order for me to make him equal to 1, I need to create ax, which is missing here. So what I do, I make this like this form. So it's going to be tangent 5x times sine 3x, and x go to 0. So here I have 5x, so I multiply here by 5x, and here I divide by 5x. So in that case I didn't do nothing. Here I divide by 3x, I multiply here by 3x. As you see, I didn't do anything, it's like I'm multiplying by 1. So here the limit of that one is 1, the limit of that one is 1. Then what's left? This, which we can simplify the x, and we'll end up having 3 over 5. So this is how you should deal with that type of question if you don't want to use L'Hopital rule. Here they ask me to use a definition in order for me to find out the derivative. So we know that the f prime using the definition is the limit of f of x plus h minus f of x over h when h go to 0. So here what is the f of x plus h is 1 over x plus h plus 3 minus 1 over x plus 3. The whole thing is over h when h go to 0. So here I make common denominator. Keep in mind this h is h over 1. So because here we have fraction, so I need to multiply by the reciprocal at the end. So it's going to be the limit when h go to 0 of x plus 3 minus here minus times the whole thing. I will distribute minus in all of them, so it's going to be minus x minus h minus 3 over x plus h plus 3 times x plus 3 plus 3 times x plus 3. So here I simplify 3. What's left is the limit of oh, I forgot here, h over 1. So here what I do, I multiply by the reciprocal because I will have fraction over a fraction. So it's going to be the limit when h go to 0 of minus h over x plus h plus 3 times x plus 3 times 1 over h. So here I cancel the h. So what's left is the limit of minus 1 over x plus h plus 3 times x plus 3, and here when h go to 0, so now I substitute h by 0, I end up having minus 1 over x plus 3 times x plus 3, which is minus 1 over x plus 3 square. So, and this will be the derivative of 1 over x plus 3. Now find the derivative of this function. So there is another statement say don't simplify. So we're not going to simplify. I'm going to just show you how to do derivative. So we know that the derivative of ln of something prime is the derivative of that thing over the thing itself. So the thing here is x plus square root of x plus 1. So if I do the limit, the f prime of x will be x plus square root of x plus 1 prime over x plus square root of x plus 1. You see the derivative of the inside over the inside. So here is going to be 1 plus x plus 1 to the 1 half prime over x plus square root of x plus 1. So here this is power rule. So anything to the power n prime is n times the derivative of the root or the base times n minus 1. So here I will have 1 plus half. The derivative of x plus 1 is just 1. So it's going to be just x plus 1 to the minus half over x plus square root of x plus 1. So you may stop here because they don't ask to simplify, or if you want to simplify, you may make common denominator. So this is going to be 2. So it's going to be 2 plus x plus 1 to the minus half over 2x plus 2 square root of x plus 1. And you may multiply by x plus 1 to the half in order for you to not have a negative exponent on the top, or you can leave it like that. That will be enough. Next, so I need to do the derivative of this one. You see this is product rule, so I know that f times g prime is f prime g plus f times g prime. So this is the product rule. So f prime will be x squared plus square root of x prime times 1 plus tangent of x plus x squared plus square root of x times 1 plus tangent of x prime. So here is just simple derivative. So here's going to be 2x plus 1 half square root of x. Here is 2x. I forgot the x here. So it's 2x plus 1 half square root of x. So square root of x prime is x to the 1 half prime, which is 1 half x 1 half minus 1. So it's going to be 1 half x to the minus 1 half, which is same thing as 1 over 2x to the half, 1 over 2 square root of x. So I just get right away to the answer. So times 1 plus tangent of x plus x squared plus square root of x. The derivative of 1 is 0. Derivative of tangent is secant square. So it's going to be secant square of x. So this will be the final answer. Next, so I want to find out the derivative for this one. This is quotient rule. So we know that the quotient rule is the following. So it's going to be f prime times g minus f times g prime over g squared. So my function will be the following. So we'll have secant x plus e to the x squared prime times 1 minus x cubed minus I will have secant x plus e to the x cube x square e to the x square times 1 minus x cubed prime, the whole thing, over 1 minus x cubed square. So the derivative of secant is secant tan, so it's going to be secant x tan x plus derivative of e to the x, so e to the anything prime is the derivative of the exponent times e to the exponent. So it's going to be 2x e to the x square, because here the exponent is x squared, derivative of x squared is 2x, so times e to the x squared times 1 minus x cubed minus, and we do the derivative of the second part, plus e to the x squared, and the derivative of 1 is 0, so it's going to be minus 3x squared, and the whole thing will be over 1 minus x cubed square. So because they don't ask to simplify, so we'll keep it like that. Okay, for that one, so this is exponent. So if I have a function to the power n, so I prefer to use backs because the backs is more simple. So to the power n. So if you wanna do the derivative of that one, so it's gonna be n times the derivative of the inside n minus 1. So here I will have f prime of x will be equal to 1/3, which is my n, yes, 1 plus sine of x plus cosine 2x prime times 1 plus sine of x plus cosine of 2x 1/3 minus 1. So here 1 is 0. It's going to be 1/3 times derivative of sine is cosine. Derivative of cosine is negative sign, but this is chain rule. So if I have cosine of something prime is minus the derivative of the inside times sine of that inside. So here will be minus the derivative of 2x is 2, and sine of 2x times 1 plus sine of x plus cosine of 2x, so 1/3 minus 1, so it's minus 2/3. You can put it as a denominator or you can leave it like that, so that will be okay. Now here, so here there's two choices to do it. I will show it to you in two ways. Either you change y, so y equal x square root of x. You use the concept of ln, so you apply ln both sides. So it's going to be ln of x square root of x, which mean this is square root of x ln of x. Then you take the derivative on both sides. So I take the derivative of both sides. So here it's going to be y prime over y. It's not 1 over y because y is a function. That means it's not, we don't do derivative independent on y, we do derivative independent on x. That means the y prime will stays. Here we do the derivative independent on x, so x prime will be equal to 1. So here I do a product rule, so it's going to be 1 over 2 square root of x ln of x plus square root of x, derivative of ln of x is 1 over x, so it's going to be just x. Now, because I'm looking for y prime, I multiply both sides by y. I multiply both sides by y, and keep in mind y is this expression. So we end up having y prime will be equal to 1 over 2 square root of x ln of x plus square root of x over x times, and I substitute y by its expression x to the square root of x. So this is one way. You can do it in different way, so by changing the form of your function. So keep in mind that if I have f of x to the power g of x is the same thing as e of g of x ln of x. You can change to this ln of f of x, sorry, ln of f of x. So here I have f of x equal x square root of x. This is my f, this is my g, so it's going to be e to the square root of x ln of x. Now I use the derivative of the exponent, which is e to the something prime is the derivative of that thing times e of the same thing, which means that I will end up to this expression at the end. So now f prime of x will be defined as e to the square root of x ln of x prime. So which means that I will have square root of x ln of x prime times e to the square root of x ln of x, and this is the same thing as x to the power square root. So I do the product rule here, so it's going to be square root of x is 1 over 2 square root of x ln of x plus square root of x, the derivative of ln is 1 over x, times e to the square root of ln of x of square root of x ln of x, which means x to the power square root of x. So either you can use that method, which is most used by students, or you can use that shortcut, so if you want. All right, for next, so here I want to do derivative of this function. So keep in mind, if I have, this is what I prefer. So suppose I have my f of x. So suppose I have my function, or my it's going to be the same thing, is f of x, g of x, and here we have my function, and we have dt, or whatever you want to call it, dt. So keep in mind, so if you want to take the derivative of this one, so keep in mind when you integrate this, you will end up having this type of function, f of g of x minus f of x. And this, if you do the derivative of this to get back to your function inside, you're going to use chain rule here. You see, you're going to use chain rule. If I take the derivative of this, I'm going to have, for example, take the derivative of this, I will have g prime, because the derivative of the inside time, we have f prime of g of x minus f prime of x times f of f prime of f of x. So this is exactly what you're going to end up with, which means that if I want to take the derivative of this one, so this is my g of x, this is my f of x. F of x is a constant, so if I take the derivative of the constant, here is going to be 0. So, but here I need to take the derivative of the inside by keeping the inside. So if I have f of x equal 1 x squared of 1 plus square root of 1 plus t squared dt, I want to take the derivative. So what I do, I keep the same function and I substitute this in. So it's going to be 1 plus square root of 1 plus x squared square. You see, I substitute t by x squared. But I don't stop here. So whatever t you have, substituted by the top one. Then I time outside by the derivative of the upper boundary. So it's going to be x squared prime always, time by the derivative. If I have x on the lower boundary, I do the same thing. I substitute this into the t, then I minus, you see I do minus, and I substitute this into t, then I take the derivative of this, I time it by this one. So it's going to be the same thing as this. It's going to be 1 plus square root of 1 plus 1 square, yes, times 1 prime. As you see, 1 prime is a constant, so this will become 0. This is why we don't worry about the 0 here. So it's going to be just 2x 1 plus square root of 1 plus x to the 4. And this you will be the derivative of that expression. The next question. So let y be defined implicitly by sine x cosine y equals sine x cosine y. So find y prime. So here I take derivative of both sides. So sine x plus cosine y equal sine x cosine y. So I do derivative of both sides. Derivative of sine is cosine, derivative of cosine is negative sine. So, but here this is y, so I'm gonna use chain rule. So it's gonna be cosine of x minus y prime sine of x equal. Here I have product rule, so it's gonna be cosine of x cosine of y minus y prime sine of x sine of y. So I'm gonna get all the y prime one side and the rest on the other side. So I'm gonna add y prime sine x both sides and subtract cosine x cosine y both sides. So here I will end up having cosine x minus cosine x cosine y. Don't subtract the cosine. You see, those are not similar terms, so they are different terms. Equal, and here I will have y prime sine of x minus y prime sine of x sine of y. You see, they are not similar, so we don't subtract. Be careful, guys, because some students make that mistake. So please don't do that. So now I take y prime as common factor. So I'm going to be sine of x minus sine of x sine of y equal cosine of x minus cosine of x cosine of y. Divide both sides by the coefficient of y prime, so which is sine of x minus sine of x sine of y. So sine of x minus sine of x sine of y. So you got your answer. Y prime will be cosine of x minus cosine of x cosine of y, the whole thing over sine of x minus sine of x sine of y, and this will be your answer. The next question. So find the equation of the tangent line to the curve y equal x cubed at the point where the curve crossed the line y equal 1. So we know that the curve crossed the line. That means there's intersection between the curve and that line. When there's intersection, that means they have a common point they share together, which means the y of that point is the same thing as that y. What we do here I have the y equal 1. I need to find out which x make the y equal 1. So what I do, I make these equations equal that one. So which means that I will have 1 equal x cubed. Obviously, I will have x equal 1. So the point that I'm going to do the tangent is 1, 1. So this is going to be your x1, this is your y1. So what is the formula of the tangent line? So tangent line will be this, y equal f prime of x1 times x minus x1 plus y1. So this is the formula that you do. This is the slope. So what I do first, y equal x cubed. So y prime will be 3x squared. So I need to find out what is f prime of 1. So which I substitute 1 here. So it's going to be just, so f prime of 1 will be 3 times 1 squared, which is just 3. So I just substitute and get my answer. So it's going to be 3 times x minus 1 plus 1. So distribute and simplify. You got 3x minus 3 plus 1. So my final answer will be 3x minus 2. And this will be your final answer for that question. So this is the formula you have to keep in mind. So how to find out the tangent line? So is y equal f prime of x1 times x minus x1 plus y1. So you need to have those two information. All right, next. Ship A and ship B leave the same port at noon. So here we have one go east. So that means one go east and the other one go north. So that means they create a right angle. So we know that the first one go at the speed of 35 kilometer an hour, and this one go at 25 kilometer an hour. So how fast the distance between the two ships is changing? So I'm looking to find out how fast this distance is changing. As you see here, you can use Pythagorean theorem. So this is my u, this is my v, and this is my w. So I know that w square equal v square plus u square. So if I take the derivative, I will have 2w. So here the derivative, 2w prime equal to v prime plus 2u prime. So divide the whole thing by 2, you end up having w prime equal v prime plus u prime. So we know that u prime is 35 and v prime is 25. So w prime is 25 v plus 35u, because the derivative is the speed. Now I need to know what is my v, what is my u, but I know that the time is 4 and the speed is 25. So if I want to know the distance traveled by A and B, so for the ship, this is A, this is B, so the distance traveled by the ship A is 4 times 35, so which is going to be 140, and the distance traveled by the ship B is 4 times 25, which is 100. So, and the distance between those two, so you already know that W will be the square root of 100 plus 140. So, oh, not, oh, you have to make a square. So square, square. So here is 100 and here is 140. So I just need to find out the square root of this one square plus this one square. So here we'll end up having, it's a big number here, so we have 100 is square root of 10,000 plus, and 40 is 196, so it's gonna be, which is square root of 296,000. So here what I do, I find out what is my W. W is 25 times U, with 25 times V, which is 100. So it's going to be 2500 plus 35 times 140 over W. So this is W prime, which is square root of 29600. So 35 times 140 is 140 times 35. So here I will have 0, this is 2, this is 7, and here we have 0, this is 2, this is 4. So it's going to be 4920. So 4920 plus 250, so is 7420. So it's going to be 7420. So you can simplify this or you can leave it like that. So it's going to be 29,600, and this is kilometer per hour because this is the unit they use for the blast. So this is how fast the distance between the two is changing. Alright, so the next, find the absolute minimum and absolute maximum of f of x between 0 and 2. So here this not local, it's absolute. That's what I need to do first. I need to find out the derivative. So f prime of this is going to be x over x squared plus 1 prime. So this is Cauchy rule, so it's going to be x prime times x squared plus 1 minus x times x squared plus 1 prime over x squared plus 1 square. So which means I will have x squared plus 1 minus 2x squared, because this is 2x times x is 2x squared, over x squared plus 1 square. So here 1 minus x squared over x squared plus 1 square. So x squared minus 2x is minus x squared minus x squared. Now I make this one equal 0, so f prime of x equals 0, which means the numerator equals 0. So this will tell me that x equal plus or minus 1. So now what I do, I look where the function. So if I do my number lines, so if you want to do that, so this is minus 1, this is 0, this is 1, this is 2. So between 1 and minus 1, so it's going to be positive, and here's going to be negative. So which means that it's decrease, increase, say increase, and here decrease. So we know now this is the local max and this is the local min. So but here I cannot decide if it's max or min. What I need to do, I know my absolute max is on 1, So the absolute max is the point 1. I substitute 1 here, so it's going to be half. And the absolute mean, I need to check what is f of 0 and f of 2. So those two, I need to find out what is it. So f of 0, it will give me 0 because 0 over 1 is 0. F of 2, it will give me 2 over 4 plus 1, which is 5. So this one is smaller. So my absolute mean is the point 0, 0. So those are the answer for that question. I put with the coordinates because they ask for the coordinate. Next question. So here they give me the derivative of a function. So this is the graph of the derivative. Find the upper interval where the function increase. So the function increase because this is the derivative. I'm going to look only the upper. You see the upper mean positive when the derivative is on the top. That means it's positive here because this is the derivative. It's not the function. Look at this. This is the derivative is f prime. It's not f. That means I will talk about above the x-axis and below the x-axis. So above is positive, that means the derivative here is positive. Below is negative, that just means the derivative here is negative. When the derivative is positive, that means the function is increased. That means the increase on that interval, which is from -3 to that side, and increase between -1 and 2. So those where the function increase. So f increase on the interval -infinity -3 union the interval -1 2 and is decreased between -3 and -1 and decrease again on 2 and plus infinite. So this is the first question. The second question, find the upper interval where the function is concave up. You see concave up mean what? This means the derivative is increasing. So where the derivative is increasing here. So the derivative is increasing here. So what does mean derivative increasing? This means the second derivative is positive, and this is where the function is concave up. But here they ask for concave down, so here I will look for the decreasing of the derivative. You see concave up, I look for the increasing of the derivative. Concave down, I look for the decreasing of the derivative, because where the second derivative is negative is when the derivative is decreased. So my B will be between -infinity and -3, yes, and 1 to infinite. So this is where the function is concave down. F is concave down. Find the x coordinate for relative max and mean for f. So what does mean relative max and mean? That means when the derivative is equal to 0. You see here? So this is where the derivative is equal to 0 on those x value. So, but which one is max and which one is the minimum? You see, this is decrease, this is increase, decrease. You see, is increase. So if I do it in terms of this is increase. Let me use another color. In that side is increase, then decrease. You see, the graph will look like this. This means is local max. Here it's decrease, you see, because it's negative, it's decrease, then increase, you see, because we become positive. This is local min. Here it's positive, that means it's increase, then decrease. That means this is what? Local max. I have two local max and one local min. So for number C, so x equal -3 and x equal 2 are local max, and x equal -1 is a local mean. Okay, or you can say relative max or relative mean. It's the same thing as local mean or local max. So next question. A cylindrical can with a top and the bottom rectangle. So this is a top and we have a bottom. That means if I want to draw my can, so it's going to look like this. So this is how the can will look like. So this is just a graph. Okay, so it's with the top. That means the top is covered and the bottom is covered. That means I have closed can. We know the volume of the can is 100. And what's the formula of the volume of the can is pi r squared times h. So define the dimension that can will require, find the dimension of the can that will require the least metal. That means we're talking about the total surface. We're looking for the least surface. So here, what is the surface of a closed can? Surface of the closed can, we have two cover, that means two circles, that's going to be 2 pi r squared plus the surrounding, which is plus 2 pi r h. So this is the surface of a closed cylinder. So to find out the least surface required, so I need to take the derivative of the surface, but the derivative here is involved two variables, so which means I need to change one variable in terms of the other. So I know that v is 100, which is equal to pi r squared. So what I need to do, I need to change this h in terms of r squared. So which means that here I divide both sides by pi r squared. So I will get h equal 100 over pi r squared. So I substitute h by my new expression. So my surface will be equal to 2 pi r squared minus 2 pi r over times 100. This is over 1. So pi r squared. So it cancel the pi and cancel 1 r. So what's left is 200 over r. So my surface will be 2 pi r squared minus 200 over r. Now I take my derivative. So it's going to be 4 pi r minus 200, but here we have minus 1, so it's become 200 over r squared, because the derivative of 1 over r prime is minus 1 over r squared. You can use the power rule here. Now, oh, you see what I did here? It's plus here. Why? You see, this is not good. So here it's positive, so that's mean I will have positive here, positive. When I take derivative, it's become negative. So this is exactly what's going on here. You see, I just mess up with the sign and everything will be totally wrong. So it was positive here, so I need to keep it positive. And when I do the derivative, so it's become minus 1 over r squared. So we'll end up having minus 1 over r squared. So now what I do now, I make s prime equals 0. So we'll end up having 4 pi r minus 200 over r squared equals 0. So which means that 4 pi r equal 200 over r squared. Now I multiply both sides by r squared, so it's going to be 4 pi r cube equal 200. So divide both sides by 4 pi. So r cube will be 200 over 4 pi. So what I do, I take the root cube of r cube, so it's going to be root cube of 200 over 4 pi. Now I have my radius, so what I do, I substitute this into here. So my h will be 100 over pi root 200 over 4 pi square. And this is root cube, by the way. So, and this is the answer for the dimension. Don't try to simplify unless if you use calculator. If you don't use calculator, just keep it as it is, because this will be enough for the question. Next, next question. A particle is moving a vertical line. So with that coordinate, you see this is a coordinate because this is a very good key. if you don't pay attention to that one, you may answer some question wrong. So here they ask me to find out the velocity. So the velocity, we just need to take the derivative, and this the acceleration, we just take the second derivative. So the velocity of t is s prime of t, which means 3t squared minus 12, and the acceleration of t, which is the velocity of t prime, which means 6t. So this is for the first question. Here they ask me if the velocity is moving upward, when it's moving upward, and when it's moving downward. So I need to do the derivative. I need to see the sign of the velocity. So I make the vt equal 0, which means that I will have t 3t squared minus 12 equals 0. So I will have t 3t squared equal 12. So t squared equal 4. If I divide by t, that means we'll have t will be plus or minus 2. So if I do my number line here, so I have minus 2, we have 0, we have 2, and here, because I know the time is positive, so we're not going to deal with the negative side, but here will give me just an idea how the thing work. So this is, if I substitute the number here, minus 3, into my velocity, so it will be positive, this is negative, and this is positive. So I will not care about that side. So which means that between 0 and 2, the vehicle is moving, or the particle is moving downward, because this is decrease, increase. So between 0 and 2, it's moving downward, and 2 and up, moving upward. Now for my last question. So find the distance of the particle travel between 0 and 3. Because here between 0 and 3 we have 2 where it's changing the direction. So what I do, I need to find out what is s of 0 minus s of 2 plus s of 3 minus s of 2. Why? Because here is the distance travel. This is 3 here. So it's moved downward. That means I will do s of 0 minus s of 2. And this is moving upward. That means I will do s of 3 minus s of 2. And we add the two expression. So we add them. That means the two numbers, we add them. S of 0 will be 3 minus s of 2 is 8 minus 24 plus 3 plus s of 3, which is 27 minus 36 plus 3 minus s of 2 is 8 minus 24 plus 3. So here will be 3 minus 11, so minus 13, so it's plus 13, and here 26, so it's going to be 20, so it's going to be 23. So here the answer C will be 20 traveled by the particle between 0 and next question. So here they ask me to evaluate the infinite integral. So we'll have the integral of square root of x plus x squared plus 1 over x dx will be the integral of square root of x over x plus x squared over x plus 1 over x dx. So this is the same thing as, let me change it to power, so it's going to be half minus 1, so it's going to be x to the minus half plus x plus 1 over x dx. So here it's minus 1 plus 1, which is going to be half, so it's going to be x to the minus 1 plus 1 minus half plus 1 over minus half plus 1 plus this is x squared over 2 and this is ln of x plus c. So here will be square root of x over half, which is just 2 square root of x, plus x squared over 2 plus ln of x. Don't forget the c. Next question. Here I do the same thing here. So here I use, this is going to be square root of e to the integral of e to the minus x sine 2x plus 4 cosine 3x dx, which is the same thing as e to the minus x dx sine 2x dx plus 4 cosine of 3x dx. So I'm going to use substitution, so u equal minus x, so du equal minus dx, so which means that dx equal minus du. So it's the same thing if I have e to the u and we have minus du. Here the substitution here will be v equal 2x, so dv will be 2x 2 dx. That means I will have dv over 2 equal dx, so here will be plus 1 half sine of v dv, and here I will have w is 3x, that means d of w is 3 dx, so dw over 3 will be dx, so here will be 4, so over 3, so cosine of w dw. Now you can simplify here, so it's the same thing as minus e to the u plus half minus, so because the antiderivative of sine is negative cosine, so negative cosine of v. So this is how I try to do this in this form. If you wanna, so this is how we do. This is sine, sorry, in order for you to memorize this. So this is sine of x, this is cosine of x, this is negative sine, this is negative cosine. So the derivative of sine is cosine, this is the derivative. Derivative of cosine, negative sine, negative cosine is sine. So if you want to do the antiderivative, so the antiderivative, which is the integral, so negative sine is cosine, cosine sine, sine is negative cosine, negative sine. So this is how you should memorize it if you want to do it in a short way. So the antiderivative of sine is negative cosine, and here is going to be 4 third. The antiderivative of cosine is sine, so it's going to be sine of w plus c. Now I substitute back everything, so it's going to be minus e to the minus x minus half cosine of 2x plus 4 third sine of 3x plus c, and this will be your answer. So next question, I need to integrate this one, so I'm going to use u equal 1 over x, so it just means du will be minus 1 over x squared dx, so which means that I will have minus du will be 1 over x squared dx. So the integral of e to the 1 over x squared dx is the same thing as e to the 1 over x times dx over x squared. This is my du and this is my u, so it's the same thing as e to the u times du. You see, this is my du, but we have a minus. There we go, and I put the minus here because this is minus du. Then I integrate, so this is the same thing as minus e to the u plus c. What is my u is 1 over x, so it's going to be minus e to the 1x plus c. For this, I choose u equal ln of x, so which means that du will be dx over x, so the integral of 1 over x ln of x square dx is the same thing as the integral of 1 over ln of x square times dx over x. So this is my du. So it's going to be 1 over u square du, which is the same thing as u to the minus 2 du. And this is the same thing as u to the minus 2 plus 1 over minus 2 plus 1, which is minus 1 plus c. So it's the same thing as minus 1 over u plus c, because this is going to be u to the minus 1. And u is ln, so it will be minus 1 over ln of x plus c. And this will be your answer. So for this one, so I choose 1 plus x is my u, which means I have to think here. I need to find out first what is my x, because I have x by itself here. So x is u minus 1. Then dx is the same thing as du. Now I substitute back, so I got u minus 1 times u to the 99 du. Distribute u to the 99, so it's going to be u to the 100 minus u to the 99 du. So what I do next? I integrate. So it's going to be u to the 101 over 101 minus u to the 100 over 100 plus c. Now I substitute back, so and my answer will be 1 plus x to the 101 over 101 minus 1 plus x to the 100 over 100 plus c, and this will be your answer. The next question. So evaluate the definite integral. So here I choose my u equal tangent of x. That means du will be secant square of x dx, and the boundary is going to be from 0, because tangent of 0 is 0 and pi over 4 is 1. Yes. So now here is going to be secant square dx is du, and e to the tangent is just e to the u. Now if I integrate, it's going to be just e to the u between 0 and 1, which is going to be e to the 1 minus e to the 0, which is e to the 1 minus 1. Next question here. So here I choose my u is 1 plus x squared. So du is 2x dx, which means that du over 2 is x dx. So here I will integrate here for because the boundary here will change. When x equals 0, u equal 1, so I'm going to put 1 here. When x equal 1, u equal 2, so I'm going to put 2 here. Now I use my substitution. X dx is du over 2 and 1 over u, so it's going to be 1 over u times du over 2. So it's like I'm doing this as this way, so it's going to be 0 1 1 over x squared plus 1 times x dx. You see, this is my du over 2, and this is going to be 1 over u. So here we'll end up having 1 half between 1 and 2, 1 over u du. So this is ln, so it's going to be 1 half ln of u between 1 and 2. So the same thing as half ln of 2 minus ln of 1. Ln of 1 is just 0. So it's going to be just ln of 2 over 2, and this will be your answer. Next question here. So here I'm going to use my u is 1 plus r square. So u will be 1 plus r square, which means that du will be 2r dr divided both sides by 2. So I got my du over 2 is r dr. So here I will end up having, if I substitute by 1 plus r by u, so I will need to change the boundary. So when r equal minus 1, so it's going to be 1 plus 1, which is 2, and 1 r equal 1, so it's going to be 2, and here will be u to the half, and r dr will be du over 2. So here you don't have to go further because the boundary are the same. And keep in mind, if I have a f of x dx is always 0, so you don't have to go further, just stop, and this is 0. Now I need to find out the area bounded by those two curves. So, but here I know that the area is always the upper minus the lower. So the upper is 2 minus x squared, the lower is just y equal x. So here what I need to do first, I need to set my integral. So I have 2 minus x squared minus x dx. But here I need to know the boundary, you see, because in order for me to get the area, I need to know the boundary. So this is where the two graphs intersect. I solve for that equation. So 2 minus x squared equal x. So which means that x squared plus x minus 2 equals 0. So x plus 2 times x minus 1 equals 0. That means I will have x plus 2 equals 0, x minus 1 equals 0. So here I will have x equal minus 2 and x equal 1. So my boundary will be minus 2 to 1. Then I integrate here, so it's gonna be 2x minus x cubed over 3 minus x squared over 2 between minus 2 and 1, and you substitute here, so you're gonna be 2 minus 1/3 minus half minus, and you got minus 4 plus 8 over 3 minus 4 over 2, and you can simplify here. So here I will have this is 2, so it's gonna be, let me do it in that way, so it's gonna be plus 4 minus 8 third plus 2, so 4, so it's gonna be 8, so it's gonna be 8 minus 1/3 minus 8/3 is minus 9/3, which is minus 3, then we have minus half, so here is gonna be 5 minus half, which is gonna be 4.5, and this will be the area of the region. So I hope you uh, got an idea what was going on that final. So thank you for watching the video, and if you have any comment, please just email me or post a comment and I will reply to you. Thank you very much for watching that review, and assalamu alaikum.